the law of conservation of mass. Welcome to this video. So we need to record this video on one Science Notebook page, and so you need to set it up like this. And we're going to come back to it, so make sure that you leave some room here at the bottom of your page. So let's get into it here. The law of conservation of matter. Of mass, of matter. This actually means the law of conservation of matter, so make sure that we record this appropriately. All right. Matter cannot be created or destroyed. It will only be converted from one form to another. So this sounds a lot like the law of conservation of energy, and as we talked about, what we could call the law of conservation of atoms. Well, atoms make up matter, and so we use the law of conservation of matter as our way to talk about this fact that matter cannot be created or destroyed. It just gets converted from one form to another. So like when a flower dies, it decomposes, and it actually, those little parts of the flower now become something new that's growing from the earth. All right, so during a chemical reaction, the amount of each element must be the same in the starting reactants and in the final products. So the amount of each element must be the same. If I start with 6 carbons, then that means I have 6 carbons to work with, and in the products I better see that there are 6 carbons. If I start with 2 carbons in the reactants, then when I finish the reaction in the products, I should have 2 carbons. So this is also the reason why some people say that we are made of stardust, because in the early Big Bang, certain elements in matter were released that have only been rearranged throughout time. And so really, our matter in our body is just at one point, or it could have been, stardust. And it's just been rearranged into making our bodies what we are today. So in order to really prove this, let's look at this first equation here. We have vinegar, remember, C2H4O2. And we have baking soda, and when those mix together, we end up making some new products, and we end up with sodium acetate, water, and carbon dioxide. And so if we actually look at water, water is going to be H2O, carbon dioxide is going to be, you guessed it, CO2. So if we actually, let's look at all the atoms that are on the left side of the arrow. So we have carbon, we have hydrogen, we have oxygen, and we have sodium. Now let's count how many carbons we have. We have 2 plus 1 here would be a total of 3 carbons. How many hydrogens? We have 4 plus 1 here would be 5. How many oxygens we have would be 2 plus these 3 would be 5 oxygens, and then we just have this 1 sodium. All right, well, if I start with this many carbons, hydrogens, oxygens, and sodiums, then in the end, I should also have the exact same number. So let's count those up. Let's see, we have carbons over here, hydrogens, oxygens, and sodium atoms. So let's count up the carbons. We have 2 here, plus 1 would be 3 carbons. Hydrogens, we have 3 here, plus these 2 would be 5 hydrogens. Oxygen, we'd have 1 here, plus these 2 is 3, plus these 2 would be 5 oxygens, and then we're left with just this 1 sodium. So if we compare the numbers on the left side, or the atoms on the left side, there's 3 carbons on the left, 3 carbons on the right. 5 hydrogens on the left, 5 hydrogens on the right. 5 oxygens on the left, 5 oxygens on the right, 1 sodium on the right, or on the left, and 1 sodium on the right. So basically what happens when we mix vinegar and baking soda is that all of those atoms just rearrange themselves into a new series of products, which means that a chemical reaction has occurred because the atoms have rearranged themselves. But this is just more evidence to help reaffirm the law of conservation of matter, and that matter cannot be created or destroyed. It will only be converted from one form into another. So it starts as one form and it gets converted into a whole nother form. This matter does. All right, so leave some room here because we will come back to this page in the black diamond. All right, see you then.